Unit 1 is Calculations and Uncertainty. It corresponds to Chapter 1 in our textbook. This should be an easy unit. Most of this is review from Chem 1. So first off, chemistry is the study of matter and the changes it undergoes. So we'll be shifting from talking about the macroscopic world, stuff that we can see, to the microscopic world, what is actually happening on the molecular level, and drawing how our atoms are changing and what they look like and how they are relating to each other. Steps to the scientific method: you have your observation, which could be quantitative or qualitative. Remember, quantitative with the N in it means numbers, and qualitative means descriptive. So you have this observation, you make a hypothesis about it, which is a tentative explanation. Then you perform your experiments to test the validity of your hypothesis. And then you have a conclusion, and based on whether or not you get the same conclusion time after time with the experiment would lead us to a theory or a law. So what would 5 feet be? That would be quantitative because it's the number 5. Blue car would be qualitative. A thick box would be qualitative. 25 meters, quantitative. Cold weather, qualitative. And 2 weeks, quantitative. A theory is a unified principle that explains a body of facts that is based, and or those laws that are based on them. So it attempts to explain why something happens. A natural law is a concise verbal or mathematical statement of a relationship between the phenomenon that we're observing, and it's always the same under the same conditions. So a theory can change depending on if we learn new facts. A law, however, always stays the same. So a law summarizes what's happening. There are 3 different types of matter. You have solid, liquid, and gas. Make sure you know the definitions of matter, mass, volume, solid, liquid, gas. These are things you should know from Chem 1. The other thing I would make note of right now is that liquids and gases are considered to be fluids because the atoms themselves can flow past each other. So if you look at our picture, we have ice. The molecules are very close together and it's very structured. Liquid, there's some space in between them, which is why they can flow, or considered fluids. And then gases, there's a lot more space between them. And again, they're fluid because they can flow past each other. Now, ways to separate out our matter in a mixture. You could use chromatography. Chromatography separates a liquid or a gas from the solid, or using a solid phase. So the components have different affinities for being a liquid or being a solid. So in our picture here, we have a black marker on a chromatography paper. It's kind of like filter paper or a paper towel, and it's in a bowl of water. As the water gets absorbed up the paper towel, the ink starts to separate itself into different colors. And that's because some of our colors up at the top will flow more with the liquid phase, so they have an affinity for the liquid phase, where the yellow doesn't, so it ends up on the bottom. Filtration, that's used for separating solids and liquids. You pour it into mesh like filter paper, and depending on the size of your solids, you can have different size filter papers. The liquid passes through, but the solid remains. Anything that's aqueous will also pass through the liquid. Since it's in the liquid, it'll still pass through. Some chemical properties and changes. If you see a color change, then that is chemical. If you form a precipitant or a solid, that's chemical. Now it has to be a solid that wasn't there to begin with. If you have the formation of a gas, you typically see bubbles. You could smell something if the gas smells. You have the absorption or release of energy. Remember, if it absorbs energy, the test tube is going to feel cold to us, and it's an endothermic process. If the test tube feels hot to us, then it's releasing the energy, and we call that exothermic. There's different types of mixtures. They can have They can all look the same. We can't see the difference. That would be like homogeneous, and that's where the word solution comes into play, which is not spelled correctly there. Heterogeneous, make sure we can clearly see with our eyes that it's not uniform, so we can actually see the different pieces and we could pick them apart. Now, a pure substance is an element or a compound. An element cannot be decomposed, but compounds can be decomposed, but they have to be done chemically. Chromatography, filtration, distillation are just 3 ways in which we can separate out mixtures. They're not necessarily used for decomposing chemicals or compounds, but we could with distillation. Distillation, it depends on the volatility, how readily it's made into a gas. So you have your mixture of liquids, you heat it up, and based on the boiling point, our gases or our liquid will turn into a gas at different temperatures. So once it turns into a gas, it goes down the condenser, and we cool it back down into a liquid. So distillation is good for separating different liquids. Remember, there's a difference between physical and chemical. Chemical, we have to see one of our 4 indicators. A physical change or property is a change in state or a phase change. The properties don't change the chemical compound or the chemical nature of the matter. So like an ice cube melting, even though we're going from the solid phase to the liquid phase, it's still water. It still has that basic H2O component.